All right. Hi, everyone. My name is Art. I'm here to talk about this open source project that I've been working on called Text2Text. And this is the GitHub for it. But the idea behind Text2Text, it's evolved over the years, but in its current form, what we're trying to achieve is to put powerful large language models in the hands of as many people as we can, and that entails offering ways to run high-performing large language models for free. So we can. There's been open source models out there, and a lot of them have failed to achieve the same performance as GPT-4. But most recently, there's been many innovations that have been open source and published, and that's what I'm going to go over today. And using those innovations and combining them, Text2Text serves the ability to run high-performing large language models for free. So in this Text2Text GitHub repo, there's a Google Colab link, which I'll click here. And this Google Colab link, and anyone can just go run. You can even run it from your phone if you wanted to, but you just run it, and it just after running. I'm not going to do it now because the models are kind of large and it takes a while to load. But you can run it completely for free on Google Colab, which is nice on a T4 GPU. And this model is based on this mixture model, which has been alluded to already in a previous talk, and it's not. Based on benchmarks, it's not as good as GPT-4, but it's like the next best thing out there, essentially. And so what is this? So what are the innovations that allow us to serve a high-performing large language model on a low resource or low compute resource environment, such as Google Colab, so that we can run things for free? And by the way, there are benefits of running things for free in private, including privacy. Let's say that if you're trying to work on some application that requires data privacy, you don't necessarily want to be sending your data to OpenAI API or whatever, and that's besides the cost of paying for it as well. So the ability to run high-performing large language models on low-resource environments is extremely important that I see. So what are these innovations? The first one is something called mixture of experts. So many of you have probably heard of it. It's MOE is for short, and it stands for mixture of experts. What is mixture of experts? Mixture of experts is it's a model architecture, or it's an approach to machine learning that allows us to activate different parts of the model depending on what the input is. So it's not like a typical machine learning model that most people learn about, which is essentially you train the weights, and then when you run inference, the data goes through all the weights so that you can get the output. The screen is too small, but so I'll just talk. I don't think many people can see this anyway. So what happens is in GPT-based models or inspired models such as Mixtro, it uses the decoder block of the original transformer model. And with the decoder block, you have essentially alternating layers of self-attention and feed-forward MLP layers. And what mixture of experts, the way that the community has gotten mixture of experts to work with this decoder transformer block well, is to replace the feed-forward net layers with the mixture of experts models. And you can guess by the name, mixture of experts means that depending on the data you're putting into the model, it will route it to certain parts. It will only utilize parts of the model that are essentially specializing or have become an expert for that particular input to get the best output. And so based on this, you can actually train a model, and then when you run it during runtime, it takes less resource to run the model because you're not utilizing the whole model. You're only utilizing the part that was specialized for that particular input. And so this was a significant advancement for the not only the open source community, but people are speculating GPT-4 is actually a mixture of experts model. And so there's that rumor going around, but of course OpenAI is not open anymore, so they don't disclose the real secret sauce behind GPT-4. So, okay, so that's innovation number one, mixture of experts. Any questions before I continue? Okay. So the second innovation is model quantization. It turns out that we can compress the model itself after it's trained, or we can compress it in various ways, but after training, post-training, you can compress a model. And there are various techniques for compressing a model, and by compressing a model, the general approach that the community has found to work well is to look at the weights and see which ones can be reduced from float 32 to float 16 to float 8 or 4-bit weights, so that you can compress the weights that way. And so this compression not only reduces the file size, but it also reduces the inference time as well. So that's another technique or approach, the second one, to reduce the resources required to run a comparable size model. There's some precision that you sacrifice and lose, but overall, if you do the compression correctly, the quantization correctly, then the trade-off is well worth it. So you take a little hit in performance, but you get a much bigger gain in the performance. Sorry, not the compute resources required. All right, so finally, the third innovation that allows us to run a high-performing large language model on low-resource environments is offloading. So what is offloading? Offloading essentially refers to running parts of the model in the GPU memory when you really need it, and for the other parts of the model that don't require GPU memory at that time, offload it to other memory such as the CPU RAM or even as SSD. And this works for the mixture of experts model, because in a mixture of experts model, as I was describing, you activate certain parts of, or you utilize the parts of the model that are necessary for that particular input. And so you're actually not utilizing the whole model. This is in comparison to the traditional transformer where you're utilizing the whole model, so you can actually just load the whole model because you know you can load the model sequentially because you know it has to go through each layer. Whereas the mixture of experts model, you can't load, you don't know which parts of the model are going to be required for a certain input, so you can't do the preloading as effectively. So it's a bit trickier essentially to do model offloading for a mixture of experts model, and so the innovation in that involves essentially heuristics of how do you guess what is the next layer in which you will, what part of the model will be used next to perform the inference on the tokens. And the name mixture of experts is kind of it doesn't truly reflect how the model dynamically selects which part of the model is going to be activated or used, because you would guess that things like, oh, if you're talking about coding, then it's going to use certain experts. If you're talking about generating poetry, it's going to use certain experts. But that's actually not what has been shown in the Mixtro model that was open source. What has been observed is that it really depends on the tokens. The experts are actually specializing in certain tokens, and so so for that reason, you can actually try to use the tokens to predict what experts are going to be utilized next, and then preload it when necessary and offload the other model parameters when you don't need it. So these three innovations essentially is what allows us to run higher performing large language models on low compute resources. So so hopefully that was informative, and this is more really educational thing here. But if you're interested, you can run the models on Text2Text. Yes.
Yeah,
question.
Is the model pre-trained? So if you clone that repo, do you have to train it yourself? Or
The question is the model pre-trained? The answer is yes, it is pre-trained. You don't have to do any training yourself.
Okay.
In fact, I see this a lot where people are talking about fine-tuning a model, And I keep thinking like, wow, they don't realize how difficult it is to actually fine-tune a model correctly. And the value and the appeal of what OpenAI did with the GPT-4 was that it made such a powerful model, it was a general use case, you don't have to fine-tune it. So, so I think that there are actually very limited use cases where you actually need to fine-tune a model.
So how big is that trained model?
Sorry?
How big is the trained model?
The question is, how big is the trained model? So Mixture was based on a 7 billion model parameter, 7 billion parameter model, but it's augmented with the 7 types of experts, so it's bigger than 7 billion model parameter size. Yes, next question.
Yeah, so I was just wondering, how do you determine what gets offloaded to GPU versus production?
Okay, so the question is, how do you determine what gets offloaded to the GPU versus what doesn't? So in the GPU memory, because you want to essentially load. Well, if you're starting off, you know you're going to load the first layer, and then you want to preload the next layer, so that when the first layer is done, you can use that right away. The question is, how do you know what that next layer should be? And so that's where I was talking about. There are certain heuristics you could use. For instance, an LRU cache, last recently used, so you can do that. But it turns out that's okay. It doesn't work that well. What turns out to work well is if you use the input if you use the input in the current layer to predict what the next layer would be and then preload that turns out that is a good heuristic.
Cool.
Okay, next question.
Are there any steps we can follow to run it on on-prem SLI bridge of GPUs, let's say in our office?
The question is, are there any steps to follow to run it on-prem? For the text-to-text, it's a Python pip library, so you can do pip install text-to-text. So however you've been setting it up, just do pip install and it'll automatically detect the GPU setup and run on it, unless you have something sophisticated that it hasn't seen. But here's the thing, like feel free to message me, anyone here, because I love talking about this stuff, and if people want to collaborate or work together, that would be awesome too. Okay, any other questions? Question here? Yeah.
Any statistics on like how much less memory it uses or how much less compute time with the mobile deployments versus the full model?
Oh, the question is how much memory does it save versus the full model?
Yeah. Is it dynamic or yeah?
So the T4 GPU that in this demo that's run that y'all can run on off the GitHub Colab notebook, that one runs off of less than 16 gigabytes of RAM, whereas the full model, from what I recall, was more on like 50 gigabytes. I have to double check because I haven't run the full model in a while, but it's substantial. Like it's yeah. Substantial. Okay. Any other questions? Question here?
Yeah, so Hugging Face also has a text-to-text. Is this like a similar approach to them, or is it you just name it?
So the question is, Hugging Face also has a text-to-text. Is this a similar thing? So it's funny. I think I'm the first text-to-text. They're after me, and the reason why is because I was working on the original transformer library, and it was called Tensor. I was a small contributor there, and this was the original library that Google open sourced, which actually gave rise to all these other models. Like it was all taken from that original Tensor library. And that Tensor library, I was working off of that, and it inspired me to come up with text-to-text because I wanted to focus on text rather than other things. So that's where the name comes from, but it's not associated with the Hugging Face text-to-text. Yeah. Last question.
Yes. Okay, so you said that you could get the models to run on 16 gigabytes of RAM as opposed to like 50 gigabytes of RAM. And part of this is due to like this like quantization stuff. Can you talk a little bit about how this might have to do with like the 1.58-bit LLM paper? Have you seen that paper?
So the question is, in model quantization, what does it have to do with 1.5-bit paper?
Have you seen the 1.58-bit LLM paper?
The other question is, have I seen the 1.5? I have not seen that 1.5.
Okay, never mind. This question is irrelevant then.
Okay, but in general, model quantization, there's been a push to reduce the how many bits you use to encode the model, and I've even read a 1-bit model or something like that. Yeah, this work actually, what I'm describing is it should work with any quantization method. It's supposed to be sort of this three-step approach. Yeah, I didn't focus particularly on quantization. Okay. All right, so I think that's enough. I took up enough time. If anybody wants to chat more, please feel free to contact me. Thank you.